When we're talking about air quality as it relates to human health, we're also talking about the microbial load in that air. And one of the things we're really concerned about is what are we breathing? We do know we have many particulate, microbial, biological particulate in the air. So fungi, bacteria. And these are very small entities. And if we think about the size, here's a ruler showing you the different division. This is in centimeter. So if you look at 1 centimeter, it's about 10 millimeter. And 1 millimeter is about, you have to divide that by 1,000 to get 1 micron. And many of the particulate that we should be concerned about in health, in human health, are those in below 5 micron, especially in the range of 1 to 2, because they tend to be retained in our lungs. So the apparatus I'm going to talk about is called Andersen sampler. And in this graph here, this diagram, it's showing how this apparatus really mimic the respiratory system of human being. So it's called 6-stage Andersen sampler. And 6-stage in the sense that the particle size is cascade in 6 different categories. For instance, the larger size are 7 micron above. The second to that would be in the range of 4 to 7. And the last category will be really small, will be small particles. So we're talking about half a micron to about 1.1 micron. So the theory behind the Andersen sampler has been based primarily on what we know about the respiratory system as is sizing this air particulate or particulate matter in the air that we breathe in. So I'm going to go now and show you the component of the Andersen sampler. So as I mentioned earlier, it's called 6-stage. So which means you will have 6 different pores in this system. It has an air intake on the top of it. So the air going to here through this system of different perforated filters. And then this is connected to a vacuum. And this vacuum is supposed to be operating about 28, drawing about 28 liter of air per minute. So as we turn it on, okay, you can see how it's sucking, sticking in my glove. So that's pretty much how strong it would be. So that's to really demonstrate to you that air is being sucked into the system. So the air draw in, so whatever is in the air is taken in, and then the air go through a pump and then exit out of the pump. Now, as we draw the air in, we have to wonder how are we to know what are the organisms in the air. So what we do, underneath each one of these perforated ring, this is the top portion. So this is capturing or letting in any particulate 7 micron and above. So we put a plate, a Petri plate underneath of it, so that when the air gets sucked into the orifice, all the particulate get impacted through this filter, through this perforated ring onto the medium. So we do so for each layer. So this is the first one. I'm going to put a plate for the second one. So this is on the top of the system, and this one is on the bottom of the system. So you're looking at particulate of 7 micron above going through here, and so any other particular smaller will go through it. And this particular ring we're talking about letting through 0.5 to about 1.1 micron. So as I mentioned earlier, it's based on the theory that's been developed from how air is intake through the respiratory system of human being. So we'll create a vacuum through the system, and I'm going to dispense a little bit of a sample through the orifice, but it helped to put a funnel over here so that it will channel the sample in it properly. So we're talking about 0.33 milligram that you can put at one time. So I'm going to tap it over, and typically it will be good to close it to kind of create more of a suction. So we'll let it run for about 3-5 minutes, but you can go longer. We've gone through this for a few minutes, so let's disassemble it and see what we got below it. Okay. So again, you can see here that if you remember, we have this spherical, this round perforation. So you can see underneath each one of them, there's been impact, okay, from it. And if we go to the next one below, I don't know how much you can see, but can you see it? See. So we will put this in the box and leave it for 5-7 days. And if there is any culturable or any organism, viable organism, especially fungal organism, then we might see some growth. Okay. And if we go further down to the third one, you could still see the impact. It's become harder to see, right? So, and let's go by curiosity to the last one. Okay. So this is the last orifice, the last ring of the bottom of it. So remember, these are letting through particulate that are half micron to about 1.5 or 1.1 micron. Okay. And it is in this range that there is most concern, as I mentioned earlier. 1 to 2 micron particulate getting into the lung tend to be retained in the lungs.
For more information on air quality along the border, please visit nmborderair.nmsu.edu. This project was funded by the New Mexico Department of Health, Office of Border Health. The proceeding was a production of New Mexico State University.